Now let's proceed with the next section. For 11.2, we will talk about the standard string class. The string class allows the programmer to treat strings as a basic data type. Thus, we don't need to deal with the implementations as with C strings, which is more complicated. The string class is defined in the string library, and the names are in the standard namespace, such as this one. Now, how do we do assignment of strings? Variables of type string can be assigned with the assignment operator, just like what we do with numeric data types. For example, we declare the following string data types, and we can simply assign one variable to another. Also, quoted strings are typecast to type string. For example, we have the following declaration and initialization of a string variable. Now, how do we use the plus operator with strings? With strings, we actually use the plus operator for concatenation. Here's an example. We declare 3 variable strings, then we concatenate the first 2 and assign the resulting value to the third string variable. In this case, if S3 is not large enough to contain the concatenated value of S1 and S2, more space will be allocated, thus making the string type more versatile. How about string constructors? First, let's recall the topic constructors. During our lesson about functions, we were already introduced to the concept of constructors. Thus, we will be referring to the same concept for this topic. The default string constructor initializes the string to the empty string. Another string constructor takes a C string argument. For example, we have the following. In this case, we initialize the string variable with an empty value, and in this case, for the second variable, we initialize the string variable with the following content. How about mixing strings and C strings? It is natural to work with strings in the following manner. For example, we have this. That is completely allowed. Although, it is not easy for C++. It must either convert the null-terminated C strings, such as this one, to strings, or it must use an overloaded plus operator that works with strings and C strings, just like this one. In this case, the first variable was initialized to an empty string, and in this case, the following variables were initialized using the following. And still, they can be used to fill in the values for the string variable that was initially declared to be empty, just like this one. And as you can see, it still works. Now let's talk about I/O with the class string. The insertion operator is used to output objects of type string, just like what we did with a regular output stream. For example, we have the following. As you can see here, we can display the contents of the string variable S using the insertion operator with cout. Also, the extraction operator can also be used to input data for objects of type string, just like this one. As you can see here, we can simply use cin, and the extraction operator to fill in whatever input into our string variable. We should take note that the extraction operator skips white space and stops on encountering more white space. Let's talk about the getLine and type string. A getLine function exists to read entire lines into a string variable. This version of getLine is not a member of the iStream class, thus it is a non-member function. The syntax for using this getLine is different than that used with cin, such as this one. Thus, the syntax for using this version of getLine with string object is the following. Please take note of the arguments that are required whenever we call this function. To understand, here's a getLine example. This code will demonstrate the use of getLine with string objects. For example, we have the following lines of code. And if we are going to run that, this will be the output. As you can see here, we use the getLine function to derive input from this variable and of course put it into the cin stream. Thus, if we are going to display its output, this will result to this. How do we do character input with strings? The extraction operator cannot be used to read a blank character. To read one character at a time, remember that we need to use cin.get. What it does is it reads values of type char, not type string. The use of getLine and cin.get for string input are demonstrated in the following example. Okay. This example will demonstrate the use of getLine and cin.get. Okay, first, we declare the following string variables. And in this case, we also initialize this variable. And of course, we will be using the same function new line from the previous examples. And in this line, we will be assigning the concatenated value of the following variables, last name and first name, and assign it to the variable record name. And of course, whatever is the value of that, we will be displaying that through this cout statement. Same also with this. And of course, in this part, we use the function getLine to do the following routine. So let's see what will happen if we run this code. So for example, let's enter our first and last name. Let's say John. Quick. So as you can see here, if we will follow the code of our example, we can actually see what happens and how the getLine function works. I suggest that you run this example by yourself so you'll be able to experiment with the following code. And that's it. Here's another version of Getline. The versions of Getline we have seen so far stop reading at the end of line marker. Getline can stop reading at a character specified in the argument list. Of course, that can also be possible. Here's an example. The code stops reading when a specified character is read. In this case, we simply include a third argument, which is actually the character which would determine when Getline will stop reading. Also, we must take note that Getline returns a reference. If we will recall, we have different types of parameters passed to a function. Please recall that we have call by value and call by reference. In this case, Getline returns a reference. This code will read in a line of text into S1 and a string of non-white space characters into S2, such as this one. Okay. So in this case, take note that doing so will return cin, which would expect an input from this variable, which is actually returning a reference to the first argument. What about the declarations for Getline? These are the declarations of the versions of Getline for string objects we have seen. Here's an example. And of course, how do we mix cin with Getline? We can recall that cin skips white space to find what it is to read, then stops reading when white space is found. Cin leaves the new line character in the input stream. For example, we have the following code. As a result, this would leave the new line character, which immediately ends Getline's reading. Then it is set equal to the empty string. We have another predefined function, ignore. Ignore is a member of the iStream class. Ignore can be used to read and discard all the characters, including the new line characters that remain in a line. The function ignore takes two arguments. First, the maximum number of characters to discard. Second, the character that stops reading and discarding. Here's an example. In this example, cin will read up to 1000 characters until the new line character is encountered. It's either going to reach the 1000 character or read a /n character or a new line character. Let's talk about string processing. The string class allows the same operations we use with C strings and more. Characters in a string object can be accessed as if they are in an array. For example, this would provide access to a single character as in an array. As you can see here, you can specify the index number. Index values are not checked for validity, so therefore, you should be careful that you actually place the correct index number. Here's an example. This example demonstrates using a string object as if it were an array. So we have the following code. we're going to enter our first name and last name. And as you can see here, our last name will be spelled. In this case, it will read our input character by character until the last character has been read, just like this one. And in this case, our last name will be displayed one character at a time. And for each index number, the character specified will be replaced with dash. So if we're going to run that, this is what will happen. Again, I'm going to enter and that's it. As we have seen here, our last name was spelled one character at a time. Let's take a look at this code. As you can see here, we read the string one character at a time. Next. We also have the member function length. I guess this is quite understandable to you. And here's how it works. The string class member function length returns the number of characters in the string object. For example, we declare the following integer variable and assign it with the value which contains the length of a string variable. We also have the member function at. What it does is it serves as an alternative to using the bracket or index-based access to an array element or string. What it does is it checks for valid index values, just like an array. And here's an example of how we can do that. For example, we declared here a string variable initialized with the string Mary. Of course, we can output a specific character from the given string using its index value by specifying its index number. And we can also do the same using the following. In this case, we are using the @member function of the string object. And as you can see, they do exactly the same thing. Let's take a look at an example. In this case, we have some other functions that we can use. Let's take a look at this and see how you can use it in your own programs. We can also do comparison of strings. Comparison operators work with string objects. Thus, objects are compared using lexicographic order. The comparison operator returns true if two string objects contain the same characters in the same order. Let's take a look at the previous example for C strings. Please recall the strcomp function for comparing the value of two strings. In this case, that was C strings. And of course, the given operators can also be used to compare string objects. I'm sure you can still remember this operator since we've already used that in our previous topic, especially in the topic in the use of control structures such as the if statement. Here's another example. We have palindrome testing. Of course, we all know what palindromes are, so we will use that in this particular example. In this case, our palindrome program will ignore spaces and punctuation. upper and lowercase versions of letters are considered the same. Here's an example of a palindrome. And for our example, we have the following function, remove punct. What it does is, of course, it removes punctuation from a string, since we are only concerned about extracting alphabets from the input. The remove punct function compares each character in the string to the characters in a string containing all the punctuation characters and the space character. If a match is not found, the character is added to the string no punct. Then, the no punct function, the original string less any punctuation of space is returned. And here's another function, the substring function, which will be used to locate a substring within a string. In this case, remove punct uses substring to extract a single character at a time from the source string. The character is then stored in the following variable. Then it uses the function find to see if the character in a car is in the string of punctuation characters. Here's the sample program. Okay. So here are some of the functions that we will need in order for us to implement the palindrome program that was shown a while ago. Anyway, here are the main functions that were mentioned in the previous slides. The remove punct function, which of course removes all the punctuation marks from the given input. And then this function converts all the characters to a lowercase character. And of course, this function returns true if the input is indeed a palindrome. Otherwise, it will return false. And this is how it is used in our main function. Of course, we are going to provide an input for our function using the Getline function. Next, this function will check if the input is indeed a palindrome. If we will take a look inside the isPal function, it will take the user input as an argument and use it in its own processing. So for example, let's take a look at the implementation of the isPal function. Here it is. As you can see in this function, it will receive the input or argument that was provided in the main function. Next, we declare a string variable which contains all the punctuation mark that needs to be extracted from the user input. Then of course, we assign the user input coming from the argument into this string variable, then turn everything into lowercase. And this time, we are going to use the remove punct function to remove all the punctuation marks from the user input and, of course, assign them to this variable. Then, finally, we perform the following. In this case, it will return if true if the user input is indeed a palindrome, otherwise it will return false. For the entire details of this example, please take a look at the entire source code and experiment with different inputs for you to observe the behavior of the program under certain circumstances. But again, let's proceed with the next one. Of course, we can also convert string objects to C strings. Please recall the automatic conversion from C-string to string, just like this one. Strings, however, are not converted to C-strings. Both of these statements are illegal. So how do we convert strings to C-strings? There should be a proper way. The string class member function CSTR returns the C-string version of a given string object. Here's an example. As you can see here, we use the strcopy function to do the conversion from the original string, and of course, by the use of this, we will be able to convert string to C-strings using the CSTR member function. However, take note that doing this is not allowed. Hence, that is why we use this function to do the conversion from strings to C-strings. We cannot simply do this using the assignment operator. It's because the assignment operator does not work with C-strings. So that's it for this section. As of this time, we are now able to show how a string object can be used like a C-string. And of course, given the previous examples, you can now write a code to read an entire line into a string object. And we can also use the string function to access individual characters into a string object.